All right, guys, let's go ahead and get on with our next set of notes. We're going to talk about similar figures and scale factor. Scale factor was covered in the first unit here at Peyto High School. We dealt with dilations along with all of our other transformations. So we're going back to scale factor. The first thing we're going to talk about is this word similar. Similar, there is a symbol that's going to mean similar. We know that the equal sign looks like. We know congruent is equal with a squiggly line above it. Well, that squiggly line above, that's what is similar. So this little guy right here, that means similar. Just a little squiggly line, a little piece of spaghetti there. Okay. The symbol, the abbreviation for is proportional to is just going to simply be a colon, 2 dots. Okay, and you'll see this throughout the notes. We'll go a little bit further here. A similarity transformation is going to highlight similarity. Transformation preserves angle measurements. So what that means is your corresponding angles are going to be congruent. Preserving the angle measurement, preserve means to keep it the same. Okay, so preserving the angle measurement means that the angle measurements will stay the same no matter how much bigger or smaller proportionally that a figure gets. The angle measurement, the corresponding angles will stay the same size. Your similarity transformation in regards to your lengths, it's the side lengths, it's going to enlarge or reduce the side lengths by a scale factor. Remember, scale factor is that lowercase k. Okay. And, no pun intended, okay, which means corresponding side lengths, they're not congruent, but they are, you heard me say it earlier, they are proportional. And that's what this will be talking about, is figuring out if they are proportional. So we take a look at the example number 1 with this diagram. We're going back to finding corresponding parts, okay? And so when we did our congruent triangles, we talked about corresponding parts. But because corresponding parts are not always congruent with this one, here we see down here, these segments, we no longer have congruent. We have that symbol I told you was going to be is proportional to. So I'm going to go through this pretty quickly so we can save some time on the video. We're looking at angle A. If you notice, angle A has 3 arcs. So on the other triangle, angle D has 3 arcs. So obviously these two are going to be congruent. Then angle B we see has 2 arcs. Angle E has 2 arcs, so angle B will be congruent to angle E. Again, pause it and rewind if you need to. Angle C has 1 arc, congruent arc, so does angle F. So that means angle C is going to be congruent to angle F. Now we go to the sides, we're still looking at locations. Now even if these are, one of those is rotated or whatever, we look at side AB, okay, segment AB. What we want to notice here is AB connects the 2 arcs to the 3 arcs. So we're looking for the corresponding side on the other triangle that connects the 2 arcs to the 3 arcs. And here we have 2 arcs to the 3 arcs. So and we want to keep our letters in order. They said AB, so from A to B, 3 arcs to 2 arcs. So here we need to say segment DE, 3 arcs to 2 arcs. So here we'll have segment DE. Very quickly through the next one, since we've already looked at this. Here we're now looking at segment BC, so we're going from B to C, from 2 arcs to 1 arc. So over here we're going to go from 2 arcs to 1 arc, EF, in that same order, EF. So segment EF. Proportional, that little colon there. Okay. Lastly, we're looking at segment CA, so we're going from 1 arc to 3 arcs. So we do the same thing for the corresponding 1 arc F to 3 arcs D. So FD. Cannot mix that around, say DF. We have to go in that particular order as we talked about with with congruent triangles. Scale factor. We need to remember, we've got a little dinosaur down here. Thank you, Mr. Barbary, for adding in our cute little dinosaurs. We're talking about our scale factor. What we need to remember about this is that the scale factor is going to be a ratio of the lengths of the pre-image, of the image and the pre-image. Okay, it describes how much a figure is enlarged or reduced from its original size. Okay, so your scale factor, represented by that letter K, is going to be represented by the length of the side of the image, your original, your new, over the pre-image, which is your old or original. So another way you can look at this is K, your scale factor, is going to be new over old, or sometimes people like to look at it as original. Okay, both start with an O, so you'll see me putting down N over O. New always goes on top, just like if you're going to paint the walls, you're going to paint a new layer of paint over the old layer of paint. That's a good way to remember that. So let's go ahead and start looking and applying these things. Example number 2 is saying use the figure below to answer the questions. Now it's saying that we got that similar thing, so these are going to be similar. So the first thing we want to do is we're going to identify the scale factor from triangle CPA to triangle FED. So what we need to see here is what's listed first is our original. To triangle FED, this is going to be our new. Okay? And our old or original, we're going from triangle CBA, which is right here, to triangle FED over here, which actually I just now realized in this video. I will make sure to make this correction on your notes so you will not have this. But let's see, correct this. That'll be F. Sorry, I'm going to pause this and correct it. All right, correction made. So back to what we're going to be doing. We're going to be going from our old, which is going to be right here to here. But the scale factor we need to remember is going to be new over old. So here we have our old. We'll go ahead and write in here K, your scale factor. We need to remember is going to be our new over the old. Meaning we're going to pick any of the 3 sides in its corresponding side. So what I'm going to do is, you guys have seen this in my videos, if you've watched my videos, I like to go through and label here, okay, here's my smaller side, here's my middle side, and here's my large side. It's going to be a good thing to do for what we're about to do. Look at the numbers. Here's my small side, here's my middle side, here's my large side. Does not matter which one you use to find your scale factor. I always go with the smaller number because, well, it's a smaller number. Why not? So let's take the smaller 2 numbers, the 12 and the 10. The new over here, 12, needs to go on top, new over old. Then we put the old 10 on bottom. We always need to simplify this, and we keep it as a fraction. We're going to notice both of these can be divided by 2. So then we're going to wind up with 6 over 5. Okay? That will be the scale factor going from triangle CBA to triangle FED. All right? You can also turn it into a decimal if you would like to as well, whatever they're asking for. Next, we're going to go the other direction here. We're going to go from triangle FED. So here, now this is our old or our original. And we're going to go to triangle CBA, which is our new. So again, with our scale factor of new over old, I'm not going to rewrite it. It's right here. Okay? We're going to take our new CBA, and I'm just, again, guys, I'm just going to take the smallest number. So over here at this triangle, we're going to take 10, and we're going to place it over its corresponding the smaller side on the other triangle, 12. And we're going to see that these are both divisible by 2 again, because all we have done is done the reciprocal. So this will end up being 5 over 6. So when you go one way to the other, your fraction of the scale factor will just flip. Taking a look at example 3, we want to know, are these 2 triangles similar? Hopefully the letters are correct. We want to justify our answer. So this is where we want to label small, medium, and large. Okay. So on this guy right here, I'm going to go ahead and on the first triangle, JKL, I'm going to find my smaller of the 3 sides right here. Here's my middle or medium. Here's my large. Same thing over here. I'm going to find the smaller of the 3, the middle or medium, and the large. What we need to do is we need to figure out if the ratio of all 3 corresponding sides comes out to the same exact scale factor. This, but we have to do it to all 3 sides now. Okay, this is kind of introduction to what we're about to do. So let's take our small side first. Okay, remembering that the JKL is old and MNO is new. You're going to see me kind of pick up this pattern where I'm going to take the one on the left as my old, the one on the right as my new. But in this case, just take what's listed first as old and here new. So take the smallest side of the new, MNO over here, 5.4, and we're going to put it over its corresponding the smaller side over here, 2.7. This one, if you put into the calculator, you're going to find out this simplifies to a whole number 2. All right? We don't need to worry about, simplifying what can go into each one. Just plug in the calculator to see what it simplifies down to. The middle number, the medium, Okay, starting over here again, making sure we have JKL first. The middle one is 8. And the middle or medium on the other one, on the other triangle, JKL, is 4. And we should all know that when we simplify this, we'll either get down to 2 over 1, which will then turn to 2. So far, both of these are correct, but we have to check that third one. The last one, the large side, again, coming over here to M and O, 10. Over here, the large side, 5. And again, this simplifies to 2 over 1, or some of you will just say 2. So yes, we can verify that these are going to be similar, and the reason why we'll say yes, I'm going to put BC for because all 3 pairs of corresponding sides are proportional, meaning they have the same scale factor. Okay, so all 3 sides ended up going down the exact same scale factor. Now, there's an easy way of doing this. We can look at all 3 angles and say, okay, well, all 3 pairs of corresponding angles are also congruent. But sometimes they'll throw a little curveball and they'll put different numbers on the sides that don't match up. So always check those sides. Next, we want to know if triangle DEF and triangle XYZ are going to be similar, and we want to justify our answer here. So let's go ahead and do the exact same thing we just did. We're going to go through this a little bit quickly. Here's our small side, our middle side, and our large side. Over here, we have small down here, middle here, and large here. I'm going to start with my small. I'm going to go from XYZ to DEF. Small is 2 over 9. Well, 2 over 9 does not simplify. Okay, so let's move over to medium. Again, going to XYZ first. Medium is 4. Over, medium over here on DEF is going to be 12. Well, this ends up simplifying to 1 over 3. So right now, these two are not matching, so automatically we know that these are not going to be similar, but we're going to go ahead and practice again with our large. XYZ large was 5, and DEF large was 15, which is going to simplify to 1/3. So if you take a look, had you done the medium large first, you'd be like, yeah, these two are the same, but what happens is that small side was not the same. Perfect example of what I just said about the angle measurements are going to stay the same, but your sides are not proportional. So you have to check both if they give you both of those. All right, last page, almost done. We're going to use this diagram of these 2 quadrilaterals to answer the following questions. We want to say, okay, quadrilateral CBAD is similar to, and we want to put everything in the correct order. So usually you'll have to have something that tells you, which sides correspond. But in this one, they are in the same position. So we're just going to go ahead and say here, we've got C, okay, down here is going to correspond with G. B is going to correspond with F. A will correspond with E. And D will correspond with H. Okay, so there's your new quadrilateral name. Okay. We want to find the scale factor used to create quadrilateral EFGH. So when we're going to go ahead and highlight create this quadrilateral. What that means here, when we create it, that tells us this is our new. Okay? So we take our scale factor of new over old. This is where I'm going to put the N and the O, new over old. Okay? Now on this one, we're going to notice we only have 1 pair of corresponding sides that both have a number. We can't use this because we have a variable. Can't use here, we have a variable. Can't use here. So we're going to have to use these 2. New is going to be EFGH, so we're putting the 10 on top. Old or original is at 2.5. When you plug this into your calculator, you're going to find out this is 4. So there's your scale factor. Okay? Next, we're going to see what the scale factor was to create quadrilateral ABCD. If you didn't pick up on the pattern I told you earlier, creating ABCD, remember this is going to be now that ABCD is the new one. So our new over old. Now we're going to take ABCD, our new one, the one we're creating, that 2.5, over the old 10, and this will simplify down to 1/4. Again, it is the reciprocal. When you go from one to the other or backwards, all you're doing is taking the reciprocal of that scale factor. Okay, 4 is 4 over 1. Flip it, you get 1 over 4. We're going to find the values of x, y, and z. I'm going to kind of zoom out a little bit so we can keep that picture in here while I do our work. I'm going to write kind of small here. Okay. The first thing, let's go ahead and find x. Well, with x, the first thing we need to remember is, let's go ahead. I just stay with the pattern. We're going to go ahead and do a proportions that we talked about. And there are some assignments, it's kind of like an assignment we did on the last, or probably did the last assignment. I just always stick with new over old. I go the right over the left unless they tell me otherwise. So I'm going to go ahead and x is up here. So I'm going to do, we're going to have to use another sign. We're going to set up proportions for this. So we're going to use the 10 over 2.5 is equal to 16 over x. Remember, we did the 10 on top, so the 16 has to go on top. You have to stay consistent with your proportions. So we'll go 16 over x. Now we're going to do our cross product, and I'm just going to draw x's here. This is going to create 10x. This will be equal to 2.5 times 16. Okay, 2.5 times 16. And again, if you just plug that straight in the calculator, that's what I'm going to be doing later on, just giving you the product. 2.5 times 16 is going to give you 40. Divide both sides, and I'm going to be leaving this up to you as well, pausing it. We're going to wind up with x is equal to 4. All right, mosey on to finding y. All right, we're going to find y now. So y is down here. We're going to have the y and the 3. I'm going to use the exact same 10 over 2.5, but this time I'm going to set it equal to y over 3. So I want you to do your own cross multiplying in your proportions. Pause it now, please. I'm going to pause mine, and the answer is about to pop up. All right, ready for your answer? There you go. She got a 12. All right, if you did not, please double check your work with mine. Now we move to our last letter, Z. I will go ahead and give you a heads up. You will get a decimal point for this one. So when you do it on your own, you come up with the decimal, there's a possibility you did do it correct. Z is going to involve the 5 and the Z. So again, the same thing, the 10 over 2.5, put that point in there, is equal to, now we have 5 over Z. Again, pause it now. Work it out. It will be a decimal. Answer's about to pop up. Please pause. Here comes your answer. You should have gotten 1.25, and there is your work. I forgot to put my cross multiplying cross product here. Okay. Now we're going to find the perimeter of quadrilateral ABCD. So when we look up here at ABCD, well, we already know what these other sides are. X we found was 4. Y we found over here was 12, and Z we found was 1.25. So with quadrilateral, the first one here, ABCD, we're just going to take all 4 of these and add them together. So we're going to have the 1.25 here, plus 4 that we found, plus 2.5, plus the 3. When we add all these together, we're going to come up with 10.75. Okay. Now we're going to find the perimeter of the other quadrilateral, EFGH. So again, we're just going to take all these numbers, add them together. It's all perimeter is 5 plus 16 plus 10 plus, we found that y was 12. We add all of these together, we're going to get 43. Now we want to know what the ratios of the perimeters are. Okay, so what I'm going to do is I'm just going to go ahead and stick with going from ABCD to create EFGH. So I'm going to go back to what we did here. We went from here to here. So EFGH will be our new. So again, let's look at our new over old in over O. And our new perimeter, EFGH, was 43. And our old perimeter, ABCD was 10.75. Again, we've got this decimal in the fraction, so we want to make sure we plug it into the calculator, and you're going to find out your ratio is going to be 4. This is actually the scale factor of the perimeter. It asks you, how do your answers from part B and G compare? So we look at B, when we went from ABCD to create EFGH, which is the side, and the perimeter, ABCD to create EFGH, we found out we got the exact same number, okay? So here, what happened, how do they compare? They are the same scale factor. And you guys are going to start seeing me put SF sometimes instead of writing scale factor. The last thing we look at is verifying what we just talked about. So here, going from here down to here, your perimeters of similar polygons. If two polygons are similar, prove it with the sides, they have scale factor, the ratio of the perimeters is equal to the ratio of the corresponding side lengths. So whatever scale factor you get for the side lengths, you use that same scale factor for perimeter. Okay? That is it for these notes. Ask your teacher any questions that you may have.